So BlueArc, we do more than blinky pens. So I'm going to cover that, and I also want to thank Dell for making the case for NFS in HPC. So that's actually going to help me go through my slides a little bit faster. Let's see if I. Oh, yeah. So just to talk about who BlueArc is first, we are a storage company, really born in the HPC space, and we have expanded from there. We were founded in the UK, actually, but our headquarters is now in Silicon Valley, California. We are being used in many of the very demanding HPC environments for both home directories, shared repositories, and also for temporary workspace for compute clusters. We've been around for a while, so we're actually into our 6th generational product. And one of our claim to fame, so to say, is that we actually have a hardware acceleration of NFS. So we do a lot of the core file system functions in hardware, and I'll cover that as well. And so far, we have basically doubled our performance with each generational product that we come up with. We're well represented, so this is just a sample of our customer list in HPC. So we're well represented by the best research universities, the government-funded national labs, and many of the big companies across the HPC-related segments out there, including life sciences, drug discovery, manufacturing, oil and gas, and so on. So that's sort of who we are. I mentioned that we started in HPC, but we also have a good business outside of HPC, so we sell into more of the enterprise side as well. So I just wanted to show this slide here, and this is sort of the reason why we've moved into that space as well. And as a company, that's a good thing to have, multiple revenue streams coming in, so we can sustain our viability going forward. So on the enterprise side, everything is basically moving to file-based storage, and we're about file-based storage. We're not doing block storage. We're focusing on file-based and focusing on standards. So NFS is really important for us. And this is sort of the essence of who we are. I mentioned that we started in HPC, so our design point is for scale and performance for HPC-like environments. So that is sort of ingrained in our DNA, if you will. We do that by using standards. So NFS is core for us. And going forward, PNFS will be added to that as well. We also add features in terms of the more of the enterprise side or the manageability side. So we have tools for how do you manage our systems at scale, how do you automate the operations, and so on, to make it easy to manage our systems. So that's sort of what on a high level, what BlueArc is about. So let's get into more of sort of the title of the talk, for how do you get performance out of these standards. So if you look at sort of what's out there in terms of file systems, it can be confusing. And I just grabbed a few names for Wikipedia here. So I missed probably a lot of the file systems. But the point is that if you look at the NAS side of this, for now, standards are good. So it really simplifies things for you as end users and how you implement file systems out there. And NFS has been around for a long, long time. So it's a well-known thing out there in terms of how do you deal with NFS and how do you manage that and so on. But I also want to recognize that we have something else out there also in terms of not really being an industry standard, but it's sort of have good spread in terms of usage. In this case, it's through Windows. We have CIFS also. So in our case, it's really about NFS and CIFS in terms of network file systems that we support today. So this is just a diagram of a regular traditional network file system, an NFS system. You have the clients on top, and you have the storage system on the bottom, and you have the link in between there. So that you have seen these type of diagrams in the past. And of course, for you as users, there are really good benefits from this. You get the simplicity and the familiarity with NFS. You also get the choice when you have multiple competing implementations. So you can choose the one that best fits your environment and the vendor you want to work with. You also have standard clients. So you don't have to deal with installing the client-side software because it's an industry standard and it's included in the OS. And that's a key thing going forward with PNFS also. So if you have that as the background, how do you actually get the most out of this? And this is sort of where our IP comes into play. First of all, you can look at that pipe between the two areas, the clients and the storage side. Make that bigger, make it possible to transfer more data. So in our case, we use a couple of 10 gig ports plus several 1 gig ports on each of our nodes. So with that, we have plenty of bandwidth capacity in terms of networking out of our boxes. We also look at the next level down, the actual servers themselves. As I mentioned, we have hardware acceleration inside our boxes. So one thing that does for us is that we can handle millions of files very easily, millions of files per directory. So going into sort of mixed environments where you need both bandwidth and IOPS is really sort of our home turf. We also put a lot of effort into availability. So we can cluster our systems on any level and do active failover and really drive availability up. Because remember that we go into sort of persistent data environments where you have home directories you want to get to all the time. You can't really afford to have downtime on the kind of environments that we go into. We sell, for example, to banks also, and they have extreme requirements on that. And then on the actual storage level, the disks, if you will, we have a tiered architecture, so we can actually use different types of technologies depending on sort of your data retention policies and where you want the data to live and what your budget is in terms of the performance you want to get out of it versus how much you want to spend on it. So with this, you can get the robust and scalable performance you need. You can do the easy capacity scaling. And in our architecture, we have actually decoupled the performance and capacity. So what that means is that when you increase capacity, you basically add disk. You don't have to add another node just to add more capacity. And that makes it really flexible in terms of scalability going forward for almost any type of environment. And then, as I mentioned, we also have a whole suite of management tools to really make it easy to manage the system at scale. So we always have that in mind, the sort of what is the scaling point you want to get to, and what kind of performance do you want to get out of it at that point, what capacity, and also how do you manage the whole system from there. So just a quick review of sort of how we make this work. I mentioned a couple of times that we have the hardware acceleration inside the system. We do that with something called FPGAs. I don't know if you're familiar with that technology, but simply it's a chip where you can download the logic when you need it. So what that means for us is that it gives us the hardware performance because it runs at hardware level. It also gives us the flexibility to add more functionality over time. So basically with a simple reboot, we get a different logic on that chip. And that allows us to, first of all, implement the standard protocols, but also to evolve it over time as the protocols change. So it has been really the core of us providing that robust performance. As I mentioned, we have CIFS and NFS as the two primary protocols today. We also support iSCSI, and then PNFS is coming in the middle of this year. We actually demonstrated PNFS at the supercomputing trade show in November as a technology demo. We haven't officially announced it yet, but it is working, and we were at a point where we can actually show that externally also at the supercomputing show. We also have a CPU inside that really deals with sort of the higher level management and signaling inside the system. And our internal file system is object-oriented. So it gives us a lot of flexibility in terms of how we manage the data internally and then export it with NFS and CIFS, for example. So an analogy here is really with sort of the networking side. So what we're doing is pretty similar to what happened over time with the routers, where they went from running it on a general purpose server with a general purpose OS to having customized OS and then eventually actually having a hardware appliance for routing. That's the path we're following for storage as well. So instead of having a general purpose server running NFS on a general purpose OS, that went to more of an appliance model with, for example, NetApp did this, and we have taken it one step further with adding the hardware to that as well. So that's sort of a comparison with another part of the market. Maybe makes it easier to understand what we're doing. So if you compare what we're doing with sort of a pure software-based solution, and you're all aware that when you get to sort of close to max with the software solution, you often see degradation in performance. So often you need to throttle the load to avoid that to happen. For us, with a hardware solution, it's a very different performance profile. So we basically take care of all the load coming in until we hit a physical limit. In our case, it's the line rate out of the box. And then we continue to execute on that level until the workload goes down again. So that's a very different way of doing it. And it gives us a much higher efficiency and much higher performance out of each box. And what that means for you is that you can have more users per filer. You need fewer filers to support the workload you have. And it's just much more efficient and easier to manage. This was a test that we did with actually Hitachi. Hitachi is one of our OEM partners. So when you buy HNAS, Hitachi systems, it's actually BlueArc technology in there. And with this, we varied the read and write mix, we varied the block sizes, and we varied how many spindles you had. So what you really want to see is independence in terms of the read and write mix. And if you sort of glance over the numbers on the right-hand side here, you can see that they stay pretty stable with a certain number of spindles, regardless of the read and write mix. And you also want to be pretty independent of the block size. So if you have a mixed workload coming in, you need to be able to handle that very, very well. But then on the other hand, when you add more disks, you need to get more performance out of it. So that's also what these numbers show here, that when we double the number of disks, we got a really big boost in bandwidth as well. Another thing that the hardware acceleration gives us is IOPS performance. So a lot of you may not look at IOPS as part of sort of looking at storage for storage performance, but it's becoming more and more important as we get more and more shared environments and more sort of mixing of different applications on the shared storage. What is actually hitting the storage is very random. And to deal with that, you need both bandwidth and IOPS performance. And our boxes are the leaders in terms of the most IOPS performance per box out there. This is sort of the family picture of the hardware boxes we have. We have something called Mercury, which is our mid-range. And then we have our high-end called Titan. And the way you look at this slide here, going from left to right, the differences between the different models is basically scalability. So if you look at the number of clustered nodes going from 2 to 8, the capacity that we support, usable capacity, going from 4 petabyte with our lowest end system up to 16 petabytes with our higher end systems. And that's behind one node or a cluster of nodes. When you get to that capacity, you usually cluster the nodes for failover. And then in terms of performance, you can see the scalability also going up to close to 2 gigabytes per second in terms of coming out of one of our Titan systems. Another thing here is that our software and storage options are common across the board. So even though you start with a smaller system, you get access to the functionality of the whole software family. This is our architecture. As I mentioned, it's a tiered architecture. So if you're a user out here, you just see one huge global namespace up to 16 petabytes. And you put your files where you think you need them to be in your directories. We take care of it from there, basically. Behind the scenes, for the administrator, we provide all the controls to actually place that data where it needs to be. And we can also automate that through rules and policies. So when data ages, for example, it can move from SAS disks to SATA disk and eventually out to tape. And through all of that, it still looks like it's still in the same space for the end user. So it's really transparent in terms of a tiered architecture, and it really works. We have been doing this for many years now, so we're proving it out. Another thing we do is we can also link in third-party, what we call third-party. So if you have any other NFS type of devices out there, we can link those into this namespace and use that capacity as well. And that really helps with migration, for example, when you move from an older system into a new BlueArc system. Just quickly, when you add this all up, we have basically strong nodes. So we can do much more with fewer nodes. And behind our nodes, we basically have a SAN, and off there we hang the rate controllers. And so you get the simplicity of NAS and the functionality and performance of SAN without having to deal with the SAN side with our systems. And that's really one of the core things that gives us the differentiation out there. So just an example, I'm covering life sciences as a segment for the company, and one of the areas there is next generation sequencing. So this is a pretty typical setup where you have instruments on the left-hand side depositing data into shared storage, roughly a terabyte per day per instrument in terms of new data coming in. And then you have a compute cluster running the ISV's applications, but also in-house applications. And that's generating a mixed workload on storage. And then you have researchers trying to get to their data, to their results. So this is a pretty typical setup where you have multiple use out of a shared storage for both compute, for home directories, and shared repositories, and with multiple protocols. So if we go back to the picture I had up here before about sort of the NAS systems you see today, the traditional network file system. And there's a lot of goodness with that, with the standard. It's a proven architecture. NFS has been around forever, basically. And what we as a vendor can do is to add to that with enterprise features, with robust scalability, and also keeping it open. So in the back end, I mentioned that the numbers I showed was with Hitachi storage. We also have DDN storage and LSI storage. So for us, it's basically a matter of qualification in terms of adding storage on the back end. Those three are the ones we support today. But the downside of NFS today is that beyond a certain point, you don't get scalability. So to get to be sort of beyond single-digit gigabyte per second, today you need to go basically to a parallel file system. BlueArc is about standards. So we've been waiting for PNFS to hit the market. So of course we have a PNFS implementation in the works. And it's ready to go, basically. And that's the one we demonstrated at Supercomputing. Well, I'm not going to steal the thunder from Brent in the afternoon. He's going to talk about PNFS. I just wanted to mention that what PNFS does is basically adding parallel I/O to the NFS protocol on a very high level. It is part of the NFS 4.1 standard, and it's approved and out there. There's also multiple implementations in development. And this is sort of part of my definition of an industry standard. You need to have multiple vendors, otherwise it's not an industry standard. And we're looking forward to doing that sort of hashing out of who's doing what best out there. And that's what we've been living with in the NFS world up until now. And now we're taking that into the PNFS world as well. And it's essentially the only parallel file system that is a standard, an industry standard. There are others out there that have lots of installations, but they are not approved by the industry committee. This is a high-level view of the architecture we're developing for PNFS. So like with NFS, we're coming out with an optimized architecture behind the scenes. So simplified, you can look at the black arrows here as the standard. That's the protocol between the clients and the metadata server and the clients and the data servers. So like with Lustre, PNFS is moving metadata out of the way. So you have these two sort of groups of systems there. What we're doing is leveraging our technology portfolio. So for metadata servers, that's a lot about IOPS performance. So we're leveraging our IOPS performance for that to come out with a really reliable and high-performant metadata server. And then on the data server side, that's more about bandwidth. But we also recognize that there are sort of different use cases for PNFS going forward. One is definitely sort of the scratch space, but you also see PNFS coming into more of the home directory space for more scalability on that side. So our design points is to really address both ways. So scratch space, where you don't really care that much about 100% uptime. On the home directory, you do. So we have options for both. So back to the view here. So on the parallel file system side, in terms of number of installations out there, it's basically between Lustre and GPFS, and Panasas is probably the third one in this space. But going forward, we believe that PNFS will be the standard choice in this space. So you'll have a certain number of existing proprietary and open source solutions, and then you'll have an industry standard as well going forward. And this is the year PNFS will hit the market. It's been a long time coming, but it's actually coming this year. And lastly, this is my last slide. The way we look at PNFS at BlueArc is really part of our overall portfolio. We recognize that every user environment is different, basically. Every installation needs a different combination of performance and capabilities in the system. And what I'm trying to do with this slide here is show that sort of a solution space. I chose to use scale up and scale out as the axis here. But the point is that it's a different combination. You can use IOPS versus bandwidth as well, or some other parameters. You need the flexibility to be able to dial in. That's the arrow here. Dial in on the solution you need for certain use cases. And the way we look at PNFS is that we're adding another arrow in our quiver with PNFS. So we can address both sort of the traditional NFS environment as well as the parallel side with PNFS. So that's what's happening from BlueArc. Any questions? Great, thank you.